Welcome to the channel Professor Davinci. Today's topic, complete binary tree. This video will be a comprehensive dive into complete binary tree, unpacking their properties, applications and implementations. I am gonna target the viewers with a basic understanding of a binary tree who want to solidify their knowledge of complete binary tree, right? So first of all, let's discuss what is the application of a complete binary tree. First application is heap. Say if you want to use a priority scheduling or priority queues, we use this complete binary tree, the first one, and the second Hoffman coding. This is one of the coding technique where we use complete binary tree, Hoffman coding. And then network routing protocols, we use the complete binary tree network. Is routing means what? It is sending a packet from a source to destination. So there's some protocol procedure we need to follow, that is called routing protocols. And in the game development, we use binary complete binary tree for spacing and partitions, binary space partitioning. And data organizations and retrieval, we use a complete binary tree, and moreover we also use this complete binary tree in artificial intelligence. Now for the viewers who don't have the knowledge of binary tree, I'm just gonna give you this brief understanding of binary tree. So what is a binary tree? Imagine a tree structure with a single node. Imagine a tree structure, suppose this is called a node, say A. Imagine a tree structure with a single node at the top. This root, this is called a root, have maximum of 2 children. So it may have, this is the 2 children, B and C. 2 children can have maximum. One on the left side is called the left branch, is called the left child, and the right side is called the right child. This is called the left child and this is called the right child. Okay, so left child and the other one is a right child. Each of these child node can then in turns have up to 2 child nodes on their own, and so on. So meaning, so for example, I can have like this one, and this left child and right child may have another set of children. Say this is a D child, this is E, you can have a F, you can have a G, and goes on. Suppose D may have only one child, E or G. Suppose H is there, so E also may have one child, F may have 2 children, J and K, like this, so on. So this produces in a hierarchical manner. We can develop the binary tree, or we can grow the binary tree. So this is so at most it must have 1 children, I mean zero child, or 1 child, or 2 children. Maximum of 2 children it must have. See, for example, the A have 2 children, B and C, and C have 2 children, F and G. B have 2 children, D and E. So this is 2 children. And D have only H, 1 child, E have 1 child, F have 2 children, and G have 0 children. So in binary tree, maximum we must have 2 children, or either we can have 0 child or 1 child. So a binary tree will not have 3 children like this. It should not have, because by means what? By means 2, binary. So always maximum of 2 children, right? Then here there are some key concept is the node meaning the round, the value where we place the data is called a node. Okay, this is this round are called the nodes. Root node, so A is the root node for this B and C, and B is the root node for D and E, so like that. So root node is the, this is the root node, A is the root node. and the parent node, and A is the parent of B and C, and B is the parent of D and E, and C is the parent of E, F and G, and so on. Then child node. So B is the child node with respect to A, and H is the child node with respect to G, and J is the child node with respect to F. This is same like a family. I hope you understood. Leaf node. The last node is called a leaf node. The last node, which is the last node, this one, which don't have any children. This is don't have any child. These are all the leaf node. Okay. Then comes the subtree. Any part of the tree is called a subtree. For example, I can say this. I will change the color of the pen. Say I make to green color. So any part of the tree. Suppose I can say this is one subtree, this is one subtree, or this is one subtree, like this. So any part of a tree is called a subtree. Okay, so this is all about a brief introduction about the binary tree. Now let's go for right, types of binary tree. There are various types of binary tree available for their specific properties. So here let us speak with three broad categories of binary tree. First type of binary tree is a full binary tree. Full binary tree meaning every node except the leaf node has two children. For example, this is the one node, though this is the parent root node, and this is the intermediate node, or we can say just a node. And here we can see that every node have two children. This is the children of 5 and 5, two children, and B have many? 2 have 4 and 5, 1 have 2 and 3, except leaf node, except a leaf. Which is the leaf here? So this 3 is the leaf node, and 4, 6, 7. If a tree except a leaf node, rest of the nodes have two children, then we can say that is a full binary tree. This is not a full binary tree. For example, have like this. This is not a full binary tree because say this node does not have another children. Okay, so this is not the full. So you should have two children except the leaf node. The rest all the node must have two children. If it is so, then it is called a full binary tree. And complete binary tree. So complete binary tree means so all the levels of the binary tree have to be filled except the leaf node. For example, we can say this is the this is the level 0, this is level 1, this is level 2. So level 0 completely filled, level 2 also filled. That means root node have two children, and level 2 this is 2 have two children, 4 and 5, and 3 have only one child, say 6. Okay, so that meaning all the levels are filled except the possibly the last level. That means say this also filled, this also filled, but this is the last level no need to be filled completely. What is the meaning of filling? For example, if you see here, the C is the third level is unfilled. The third level is, the second level is unfilled because it should have this one, it should have this one. This is the filled one. But now though it is a last level, this is the last level, it may be allowed to not to have filled. Okay, if it is so, this is called a complete binary tree. Repeating once again, I draw a complete binary tree. I draw a one node 1, so the node have this one. So in this case, this is a, say this is a level 0, this is a level 0, level 0 is filled. This is the level 1. Level 1 now, as per this one, level 1 is the last level, so this is unfilled, right? So no problem if it is unfilled, no problem. So this is counted as a, it is considered as a complete binary tree. So not necessary to fill this one. Last level may not be filled, but before the level must have to be filled. Now let us continue this one. So I'm just continuing this one, number 3. I'm just continuing number 3, then I have number 4. Okay, now as per this one, this is the last level, number 2 is the last level. So first level is 0th level is completed, first level is completed, then second level not completed, no problem. So that means before the last level all the node must be present. If it is so, then it is called a complete binary tree. Moreover, we have to fill the node from left to right. If I have one more node 5, I should not fill here, because here we should not miss it, you should not miss this one. Okay, so that means always I need to fill from left to right. Always I need to fill the child from left to right. I should not skip it. So here in this case, if I want to have a 5, I should not put that 5 under 3, I have to put this one under 2, because I need to fill the each one. I need to fill this one. After filling this one, then I have to go for the child of third node. Clear? So this is the complete binary tree. Now the third one is perfect binary tree. Perfect binary tree is a special type of complete binary tree where all leaf nodes are completely filled and all the leaf nodes are at the same level. So here, if you see here, if suppose if I don't have this one, okay, if I don't have this one, so this is the complete binary tree. But even though it is complete binary tree, see the leaf is not in the same level. So 2 leaves are in the level 2 and 1 leaf in the level 1. So if it is so, this is the complete binary tree. So in a perfect binary tree, all the leaf must be in the same level, that is the last level. What is the last level? This is level 0, this is level 1, this is level 2. Okay, so a special type of a complete binary tree where all levels are completely filled, all the leaf nodes are at the same level, that meaning perfectly triangle, I mean equilateral triangle, we can say. So completely filled. Okay, it forms a triangle. If it is formed, then it is called perfect binary tree. Clear? Now, so far we have seen what is a definition of what is a complete binary tree, where we use complete binary tree. To understand complete binary tree, we need to understand what is binary tree. So I had just told about what is binary tree, what is a type of binary tree. Now we go for what is the uses of a binary tree. Benefit of binary tree. Binary tree is used in hierarchical organization. What is meaning of hierarchical organization? Hierarchical organization means data is organized in a parent-child relationship, make it efficient for searching and sorting. That is a so in hierarchical organization we use binary tree. So what is hierarchical organization? Data is organized in a parent-child relationship. So here also, if you see any binary tree, what is the relation of 1 and 2? So the relation of 1 and 2, it is the parent for this child, this is for 2. Okay, so that means 2 is the child of 1, or else 1 is the parent for 2 and 3. Same way we can go further. So 4 is the parent from 2 is the parent of 4 and 5, or we can say 5 is a child of 2. Okay, so if we want to have a parent child relationship in any data organization, we can use this binary tree. Okay, second, dynamic structure. Node can be easily added or removed, allowing the tree to adapt to the change of data set. So for example, if we have fewer data, we can construct a binary tree with the relation. But in future, if we have more data will be added automatically, will be added without any harm, without any additional computations. So in this case, I can grow the binary tree, or I can even shrink the binary tree based on the need. So that is called dynamic structure. Then efficient memory usage. Efficient memory usage, binary tree can be compact compared to other source of other sort of data structure. Then searching binary search tree allow the efficient searching. So there are many searches out there. In that, one of the best search is the binary search. So if you implement the binary tree for a particular for the data set, then searching will be very easily. Then heap, to prioritize the element based on the value, often implement using complete binary tree. So that is why based on the priority, if you want to give the priority for any data set, so we can use the set as a heap. So that heap is implemented using binary tree. Then file system, directory structures in computer systems can be modeled as a binary tree. Then finally, the game development, used in a technique like a binary spacing partition for efficient rendering and a collision on the reduction is used in a game development. So in this game development, we use binary tree. Clear? Until here, it is a short brief history or brief explanation about a binary tree. Now going to the scope of this video. Complete binary. The scope of the video is complete. What is about complete binary tree? A complete binary tree is a special kind of binary tree where some specific rules are followed to fill the level of the tree. Okay, so it's a binary tree, but there is some rules and regulations are there to fill the complete binary tree. So here are the some properties. So first property, all the levels are completely filled except the last level. So already I said all the levels. So where is the tree here? This is the complete. This is complete. So all the levels are filled except the last level. Last level is not filled because it can fill like this 7. Okay, this is the first property of the complete binary tree. Then has the maximum number of nodes it can hold. The last level, however, can have some missing nodes on the right side. So I told you always you need to fill the complete binary from left to right. So already I told. So you need to fill from left to right. We can ignore the right side may be empty. Right side may be empty, but the filling must be done for left. So that's why I thought from we need to fill from the left to right. This is the first property. The second property, all leaf node are the same depth. Since the last level is filled leftwards, from the left, all leaf node will have the same level from the root. So that meaning, so already I told you the complete binary tree means we need to fill from the we need to fill like this. So the last level have the same depth. I mean the leaf node last level will have the same depth from the root node. Number of node has specific depth. What is the depth? The level is called a depth. The number of node at a particular depth d in a complete binary tree is always equal to 2 power d. It always the what is the 2 power, if a complete binary tree will have 2 power d nodes. This property is useful for calculating a total number of nodes in the tree. For example, 2 power, what is the level depth 2 equals 4. So in level d, what is the maximum number of children? Here we can have maximum number children 4. So 4 5 6, and we can have here some, right? So this is the meaning here. At level d, the maximum number of children is 2 power d. Relationship between the height and the number of node. The height of the complete binary tree with n node can determine using the following formula. So the height of the node is determined by log of n plus 1. Okay, so this formula have to establish the relationship between the number of node in the tree with respect to the height, and the last property is the efficient uses of a space. Of course, the binary tree is a efficient using the space. Same property is high inherited to the complete binary tree also. So the complete binary tree also uses the space efficiently. Clear? So this is all about complete binary tree. Now what's the real world application? The heap, I mean pre-RT queue is the real world application of a complete binary tree. Clear? So this is all about the basic information about the complete binary tree. So I hope you understand. See you guys. Have a great day.